If only time travel were just that simple, to directly jump from one time period to the next when only achieving a speed of 88 miles per hour is quite impractical. Although it does slow down time, or at least for the passengers in said vehicle. For example, if I was standing by the side of a two-lane road observing a car pass by at about 50 kilometers per hour, I would be traveling through time at a faster rate than the car, because the car's velocity is 0 and 14 thousandths more than mine, or so it seems. My character may not be walking, however, I am still traveling a distance, which is the speed of the Earth's rotational and directional movements. Yet the car still remains about 50 kilometers faster than my speed if the Earth's speed is added to both our velocities. We can add the speed of the solar system, galaxy, or universe if we desired instead, depending on what and how we're comparing. After all, there are an infinite number of concepts moving at their own speed throughout the universe, and potentially beyond. Take the twin paradox, for example. If a set of twins were separated at birth, where one twin was raised on Earth, and the other was sent on a rocket ship with the supplied necessities for a lifetime survival, after 60 years on Earth, the twin whom lived on Earth would obviously be 60 Earth years old. However, the twin sent to broad space in a ship would be younger. This is because the space twin was traveling at a much higher velocity than the Earthling. So this twin is experiencing a longer travel in the same measure of about 60 Earth years, which the Earthbound twin is experiencing. Therefore, in order for the twins to reunite, the distant twin must turn back to Earth midway along the journey, and so as the Earth twin has been going in a projected time frame, the twin on the spaceship has been going at a constant velocity to and from the starting point in Earth, where the transition of direction is made 30 Earth years after the experiment had begun, according to Albert Einstein's special theory of relativity, that is. This could also explain why a different planet that hosted other life, such as Kepler-22b, the planet that has been assumed by NASA to potentially sustain extraterrestrials among it, could not only be a part of an alternate time zone, but could be traveling through time at an alternative velocity with its different gravitational pull. Meaning, the inhabitants of Kepler-22b are aging at a diverse rate in contrast to objects on Earth, and may also have different intervals of acceleration in which the population moves by. Similar to the time zones used in clusters of regions around the world, where two of these areas are compared by the difference of hours in which their zone time is behind or ahead. Now let's go back to our plot and say the driver honked the horn of his or her car when passing by. According to the Doppler effect, the car's horn will gradually become louder and louder as a series of waves going at a speed higher than that of the car, with the appropriate environmental conditions, that is, until the vehicle directly passes by me and the sound's waves soon become more spread apart as the effect of the sound is reversed and becomes more quiet and distant. Yet the sound of the horn was and still is traveling through time as a concept. From my perspective, the sound waves of the horn were moving towards the right, creating a higher frequency when the car was entering, then decreased as the wavefront spread out towards the left of its source while the vehicle was passing. Now let's add a new variable to our story. A truck going at the speed of 70 kilometers an hour. This time, the truck has a higher velocity than the car, and hence, traveling slower through time, while I have still remained the fastest time traveler in this scenario. Well, only relatively to the truck and car, and many other things in the universe as well. This is because in Einstein's theory of relativity, almost everything, with one discovered exception, is relative to each other. Every concept is getting compared to in some sort of measurement or standard. For example, if there was a roundabout with a rotational speed of 6 kilometers per hour going in a clockwise direction and I was walking counterclockwise at a speed of 5 kilometers per hour, from my view, the roundabout is spinning at 11 kilometers per hour, excluding the speed of the Earth. But if I stopped walking, I would notice 6 kilometers per hour instead. So what if I started walking in the same direction as the roundabout? Then the roundabout would look to have a rotational speed of 1 kilometer per hour until I stopped walking once again. These velocities and accelerations are all relative to each other. That's why there is no true meaning of beauty. To call someone or something beautiful is to compare that thing to some other previous object and weigh the results based on your own knowledge and experience. So everything around us is relative and will always be in motion, and for this reason, we're always traveling through time at our own pace, but not only on Earth, but also in the whole entire universe as well. Unless if we introduce black holes to this theory, in which scientists to this day have pondered over what goes on inside a black hole. Traces of time have stopped at the start of black holes and are being sucked inside. Yet wormholes were said to be able to connect two destinations in space and time. This discovery by Nathan Rosen and Albert Einstein could allow time travel through the future or past if one opening of the wormhole was accelerated to a speed very close to the speed of light and then turned back to its initial state. At the same time, the other end of the wormhole would maintain no apparent motion so that the opening would travel through time less slowly than the maintained end. Meanwhile, in our example, if we built a silo next to my character and introduced another person sitting on top of the silo going at the same speed I'm moving at, the person on the silo would still be traveling through time faster than I am, even though our speeds are alike, due to the fact that there's a stronger gravitational force acting upon my person than the being on the silo. So gravity also affects the rate at which people move through time. Nevertheless, gravity can also bend light in space-time. For instance, the sun's gravitational pull can cause humans on Earth to see the position of a star differently, because the star's light will run through a large body, which in this case is the sun, so the light passes through the smallest distance curved in space-time, whereas our eyes alone do not see this route and pinpoint an alternate starting location for the star's light. But when the light comes across a black hole, the mass of this invisible star would be so concentrated that the curvature of space-time this black hole produces would be infinite. And since its gravity is very strong, the light will get dragged in the black hole without any escape that has been discovered yet. However, the universe is filled with varying galaxies that may lead to other dimensions or past and future eras. The film Down the Rabbit Hole agrees that each galaxy has a different dimension. Our galaxy, the Milky Way, is said to be in the third dimension by Albert Einstein's theory of relativity. However, the string theory disagrees and states that we are currently undergoing the fourth dimension with 11 dimensions total. The truth is yet to be proven until further discoveries. Meanwhile, we can enjoy the knowledge we have built so far. Thank you for watching. The end.